Hello and welcome to today's lesson where we are going to take a look at some aspects of A-level paper 3 vectors. Now, as you can see on the screen, we have a question where we have been given three sets of coordinates which are 3D, from which we are required to find a vector equation of one of the lines, find the midpoint of that line, and then find the equation of the line MN based on those conditions, which we shall take a look at, as you can see. Now, so without much further ado, let's jump straight into it and show you how we can do this. So you will see that from the first from the first question, we need to remember one or two things there. Firstly, we need to remember the general vector form of any equation. We need to remember it. It will come to our aid. Secondly, we need to be familiar with the use of our Cartesian coordinate plane. Now, that will also come to our assistance here. So, let me show you what I am talking about here. If we are given a set of coordinates, suppose that's A and then that's B in space, then we know if we bring in the origin, this is our set of vector lines which connect points A, B, and the origin. Now, we also can now write the general form as R is equal to OA plus lambda AB. Right. OA refers to the origin, so to speak, of the vector line that we are talking about, right? So in this case, since we want to talk about AB, this is the origin, right? Or the location. AB gives the direction of that vector, right? So the lambda now tells us that, basically tells us how far along the line AB you can go. So it can take fractional values, it can also take integral values, but it cannot take zero values, right? So for the first part, where we are required to find the equation of the line AB, all we simply need to do is to first of all find AB. We already know OA, right? So to find AB, we simply consider the coordinates of B and A. We subtract the coordinates B minus A, which is going to give us minus 3, 4, minus 5, subtracting the coordinates of A, minus 1, minus 2, 1, and then that's going to give us minus 3 minus minus 1, that's minus 2, 4 minus minus 2, that gives us 6, and minus 5 minus 1, that gives us minus 6. So those, or that is our answer there, right? So I'm sure you can see that you can factor out 2 throughout and divide by 2, you will still get the direction. So this is what I was talking about when I was saying you can have multiple values for the direction. This corresponds also to a certain value of lambda. Hence, our final equation will be r is equal to OA. We already have the coordinates, minus 1, minus 2, 1, plus lambda minus 2, 6, minus 6. That is our final answer for the first part. Now, moving on to the second part, where we are required to find the coordinates of the midpoint M of AB. So, still, that's A, that's B, it's A, B, and suppose that's the midpoint there, right? Now we can use the vector equation that we got from the previous part to find the coordinates of that M. Our lambda in this case is going to be half. So all we do is to plug in the value of half into that equation, where now we're going to get R is equal to, we have the coordinates OA, minus 1, minus 2, 1, plus half, the coordinates that we got here, which are minus 2, 6, minus 6, and this simplifies to so if you divide everything inside the brackets by half, you are going to get this is going to give you minus 1, and that's going to give you 3, and that's going to give you minus 3. And so we are going to get our answer as minus 1, that's going to be minus 2, then minus 2 plus 3, that is positive 1, and the final part here, 1 minus 3, that's going to be minus 2. So these are the coordinates. So as you can see, we simply used the equation to find the coordinates of the midpoint, right? So those are the coordinates. Now, let's move on to the final part. We've been told the point N lies on BC, and given that twice the magnitude of the vector Bn equals the magnitude of NC, find the equation of the line MN. So again, we stick to basic principles. Suppose our A is there and our B is there, right? And that is the line joining them, and that's M. And suppose C is here. It could be anywhere really, right? So that is the vector that is joining B to C. At the same time, we have a point N which is along BC, and from what we've been given here, twice the vector Bn is equal to NC. So if we multiply this Bn by 2, we're going to get that. So which tells us that N is actually a third. N is a third. Okay, 1/3 along BC. This is all that the statement means. So here, right, that's our vector line MN. So to get to N, you can come from MN directly, or you go via B, and then you go 1/3 of the way along BC, and then you get to point N, right? So clearly we can see that MN, right, is going to be, okay, this MN is going to be equal to MB plus BN. But we know that Bn is a third of BC. So this now becomes MB plus a third of BC, right? So this will allow us to find the coordinates of N, right? So what is MB? We do that here. MB is equal to coordinates of B minus coordinates of M, which is going to be equal to minus 3, 4, minus 5, subtracting M, which is minus 2, 1, minus 2, and that will give us minus 1, 3, minus 3. So that's your value MB. Now, what about BC? Right? Same technique, C minus B, which is going to be equal to 0, minus 2, 4, subtracting minus 3, 4, minus 5, and this gives us 3, minus 6, and 9. All right. So now we can plug these values into the general equation so that we find the coordinates of N, right? So we're simply putting the value of MB, right, as well as the value of BC, right? And we know that our lambda is 1/3. So that makes everything simple. So now we are now going to say MN is now going to be equal to minus 1, 3, minus 3 plus 1/3 of 3 minus 6, 9, right? So 1/3 of minus 3, 6, 9 is going to be 1, minus 2, and 3, right? You can work that out, and that is going to give us 0, 1, 0, right? So this gives you the general direction MN, right? So now we know this, but we know that the line is starting at M. So this is where everything is starting. So hence we are going to write our equation as R is equal to, so we have the coordinates of M. They have been given as minus 2, 1, minus 2, plus lambda. Then we simply plug in our value of the direction there. Quite easily done. I hope this is clear, and I hope this will help you to answer similar questions. So, till then, till we meet again for another lesson, let's end here for today.